Okay, so we're going to review for our test tomorrow. Test will look pretty much exactly like this. We'll go through these problems. You get to use this review on the test. And here we go. Evaluate the expression for x equals 2 and y equals 4. You, of course, need to show work whenever possible. So since this gives you the opportunity to show some work on here, I need to see the substitution for each of these values that they give you. So I want to see you write out 8 times 2 squared plus 4 times 2 to the 0 power times y. Whoops, I should not have put a y. What do I need to put there? 4 to the negative 1 power. 4 to the negative 1. We have to think about all the rules about exponents and how they interact with one another here. So the first thing is order of operations. I have to do exponents before I do anything else, right? So before I do 8 times 2, what do I have to do first? I have to do 2 squared first. Exponents come first. Okay, so I have to do 2 squared. That's going to be 8 times 4. Everybody understand how I got that?
Yes.
2 squared is 4. We have to do that first. And then I want to do plus 4. And then what is 2 to the 0 power? 1. 4 times 1. And then what happens when a number has a negative exponent? It turns into a fraction, so I need to do times 1/4. That would be 4 to the negative 1 power, makes it a fraction, okay? Now I can do my next step, which would be to multiply. I have to multiply before I add, right? So 8 times 4, that's 32. Plus 4 times 1 is 4, times 1/4. What's 4 times 1/4? 4 times 1/4. 1. So it comes out to be 32 plus 1. The answer to that question would be 33. Guys, it's an order of operations question. That's primarily what this is. You've got to do everything in the right order. Make sure you do exponents, do your substitution first, then do your exponents, then do your multiplication, division, then do addition, subtraction, okay? Write everything out. You've got to show work on that one. All right. Everybody good with that one? I need to clear it so I can move to the next one. Move my paper up here. Clear. Simplify each expression below. So if it has a negative exponent that's not simplified, this first one, you can't see it very well on the screen. I hope you can see it better on your paper. It's 7 to the negative 7th, right? 7 to the negative 7th. I don't want a negative exponent. What do I do to fix that? 1 over x to the 7th. And guys, if you want to take notes on here, that's okay. If you want to put down next to this one like no negative exponents, or make sure that, you know, something like that to help you remember why you did this. Negative exponents make fractions. Something like that to help you remember. That's okay. All right, this next one is division, correct? X to the 8th divided by x to the 5th. Subtract the exponents. Keep the base. Subtract the exponents. We put that in the notes when we took notes on this unit. Keep the base, subtract the exponents when we do division. If you want to write that down on your note page, that'd be a good thing to do. Subtract the exponents. That one is, whoops, didn't mean to do that. That one is division of powers. This next one is power of powers. What do we do with the exponents here? Multiply the exponents. So this would be x to the 20th. Write that down if you want to. Multiply the exponents, power of powers. The next one is product of powers. We're multiplying two bases that have the same, or that have, they're the same base with different exponents. So what do we do with the exponents? Add them together. So this is product of powers. We're going to keep the base and add the exponents. X to the 12th. And then finally, what happens if I have a negative exponent on the bottom of a fraction? It's got to go to the top. It's got to make it like a whole number. So it's just going to be x to the positive 5th. All right. Everybody good with that part? Any questions? Want me to restate any of those rules? All right, we're going to move the screen up here. See it better. Write 5.3735 times 10 to the 12th in standard form. So this exponent, 12, tells me how many times to move that decimal. So I would need to move the decimal 12 times 5735. And so far, the decimal was here, and I moved it 1, 2, 3 times. I need to keep moving it, so I need to put 9 zeros now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have moved the decimal 12 total times. The decimal was right here, and I moved it over 12 times to get it all the way to the end. With a negative exponent, we again need to move the decimal 6 times. This time we're going to move it 6 times to the left, which means I need to put some zeros in front. And if I just put 6 zeros, three, 5, 9, 1, and I put a decimal after my first 0, that's the right spacing. Because it was here after the 3, and I moved it 1, 2, 3, 4, 5, 6 times. The exponent is just telling us how many times to move the decimal point. What power of 10 we're multiplying by. Everybody good on the front page? Page 2. Oh boy, we got to multiply. So when we multiply, and I think there's just a couple of these on here, so which expression is equivalent to 7.2 times 10 to the 5th times 4.3 times 10 to the 8th? First thing I need to do is multiply 7.2 times 4.3, and I'm guessing when you do that, you come out to 30.96.
Yes.
Okay? Do I want to leave it as 30.96?
No.
No, because that's not scientific notation. I can't leave the decimal in that spot. So I need to have one of these three. So it's going to be 3.096. I didn't put a 0. 3.096. And when I do 5 plus 8, I get 13. But then I moved the decimal once, and I made that number smaller, so that number has to get bigger. So it needs to go to a 14, right? 3.096 times 10 to the 14th. It's tough to do with this little writing utensil. See if I can do, if I just do this, it'll be better. A little bit better.
Yep.
I don't know who chose the color, by the way. I did not choose that color. All right. Okay. Everybody good on that one? Multiply the two factors, make sure your decimal's in the right place. All right, rewrite 5 to the negative 15th using a positive exponent. 1 over 5 to the 15th power. That one shouldn't be too big of a deal. Let's clear that so I can move my paper up. In 1902, the yearly attendance at a Major League Baseball park was 3.4 times 10 to the 5th people. 100 years later, the yearly attendance was 1.7 times 10 to the 6th fans. How many times greater was the attendance in 02 than in 1902? So is this a division problem? How many times greater means they multiplied to get the answer. So we need to work it backwards, which is divide. Okay, so we are going from 1.7 times 10 to the 6th, and we're dividing by 3.4 times 10 to the 5th. Okay? So 1.7 divided by 3.4. 0.5? 0.5. This, by the way, this is one you need to definitely show some work on. And then what do I do with my exponents? Subtract. Since we're dividing, you subtract. Times 10 to the 1st. 6 minus 5 is 1. Can I leave it like this? No. Nope. I've got to move my decimal to make this number bigger, which means what do I do with this number? Make it smaller. So it's going to be 5 times 10 to the 0 power. What is 10 to the 0? 1. So 5 times 1 would just be 5. So it's 5 times more people seeing the baseball game in 2002 than in 1902. But leave it in scientific notation. This is just fine right here as it is. Whoops, I cannot draw very well with this thing. All right, find 9.3 times 10 to the 6th plus 1.8 times 10 to the 4th and express your answer in scientific notation. This is one we've been working on over the last couple of days. I cannot add numbers that don't have the same exponent, so I need to change this 6 into a 4, right? And how do I do that? I need to move the decimal 2 times and lower that number 2 times. So it's going to be 930 times 10 to the 4th. And we're going to do plus 1.8 times 10 to the 4th. So 930 plus 1.8 would be 931.8 times 10 to the 4th. That looks like 104. I didn't do that good. 10 to the 4th. And then my last step is to fix the decimal. So I need to make this number smaller. 9.318 times 10 to the 6th. On problems like these, I know some of you are still feeling like these are pretty tricky. Guys, if you show some work, if you show me that you attempted, you'll at least get partial credit. Try something, don't just leave it blank. If you leave it blank, I can't help you. If you try something, you'll get a point for trying. All right, write 8,340,000 in scientific notation. The decimal in this number is right here at the very end. Where do I need to move it to? Between what two numbers? Between 8 and 3. So 8.34. How many times did I move the decimal to get it there? 10 to the 6 times 10 to the 6th power. I moved it 6 times. And then this one, I'm gonna move it from here to between the 7 and 8, so 7.843. And how many times do I move it? 10 to the negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I agree, 8 times. All right. Okay, how are we feeling? All right. Any final questions over this page before I turn you loose?
Nope.
All right.